Problem 5. A packet communication system consists of a buffer that stores packets from some source, and a communication line that retrieves packets from the buffer and transmits them to a receiver. The system operates in time slot pairs. In the first slot, the system stores a number of packets that are generated by the source according to a Poisson PMF with parameter lambda. However, the maximum number of packets that can be stored is a given integer b, and packets arriving to a full buffer are discarded. In the second slot, the system transmits either all the stored packets or c packets, whichever is less. Here, c is a given integer, which is between 0 and b. Assuming that at the beginning of the first slot, the buffer is empty, find the PMF of the number of packets stored at the end of the first slot and at the end of the second slot. B. What is the probability that some packets get discarded during the first slot? What do we know so far? Well, we know that it's a Poisson PMF, right? And that the maximum is an integer b. So first what we want to do is we want to find the first slot, or the first system, right? We want to do part A and solve for the first slot. Now let us remember the equation for Poisson PMF, which is e to the power of minus lambda times lambda to the power of k divided by k factorial, right? Now, if this confuses you, that's fine. It is a bit confusing. Basically, this is the probability that k packets will have been produced. So if we put input 3 here, so if we input 3 as our k, this will be the probability of having produced 3 packets, right? So we can actually write the probability of producing 0, 1, all the way to k packets is e to the minus lambda, lambda to the power of k divided by k factorial, right? Well, there is only one part here we have to be careful of. We have a maximum number of packets that can be stored, right? Now, this reminds us of one of the previous questions that we solved that also had a maximum. Okay, so we can say the probability of having produced 0 all the way up to b minus 1 packets is e to the power of minus lambda, lambda to the power of k divided by k factorial. So far, so easy. Now, when you hit b, right? So let's say b is equal to 5. Let's say the max amount of packets we can store is 5. What is the probability of having 5 packets stored? Right? It's the probability of having produced 5 packets plus the probability of having produced 6 packets plus the probability of having produced 7 packets all the way up to infinity. So we actually have to make a summation here, right? We have to make a summation. So we can set the summation to be from b all the way to infinity, right? Because look, here we said that 5 is our max and we had to start the summation at 5. We shall then become e to the power of minus lambda, lambda k, divided by k factorial. Now, there's also one other way to find this answer, right? We know that the summation of all of px's, right, is equal to 1. So if you sum up all of the probabilities, it's 1, right? Now, we have two parts. One is this, right? Which is this right here, right? As you can see, this is the same as this. If we sum all of these up from 0 to b minus 1, we get all of the probabilities, we get all of the probabilities here, right? So we can actually say 1, why is this here? We can actually say 1 minus this is equal to this. So again, okay, that might have been a bit confusing. We can say the probability of 1 to b minus 1 plus b minus 1 to infinity is equal to 1, the probabilities. So we can say 1 minus all of the probabilities from b minus 1 is equal to the probability of b minus 1 to infinity. Now, to move on to part B, right? And here is actually where it gets kind of confusing and difficult, so pay close attention. let us say X is the number of packets in slot 1, Y to be the number of packets in slot 2. And we know that we are either going to discard C or B packets, amount of packets, right? So what formula can we write for Y? Well, actually, let's think about this. Let's say that C is equal to 20 and X is equal to 10, right? So what will Y be at the end? Well, we discard whichever one is less. So we would have 10 packets and X is smaller, so we would take out 10, we would be 0. If C was instead 5, C would be less, so we would take 10 minus 5 equals 0. So here we're taking whichever one is smaller. So either C is smaller or X is smaller, and that's the value we're taking. So we can say that Y is equal to X minus the minimum of X and C, whichever one is smaller. Okay, now let's say that X is less than C, right? So say that X is less than C. What happens? Well, Y is equal to 0, right? Because it will discard X amount and we already have X amount, so Y is equal to 0. So the probability for this will be the same as the probability of Y being 0, which is the probability that we get X less than C. Now, if C was 5, this would be if, like, let's say C was 5, this would be the probability that X was 1 or X was 2 or X was 3 or X was 4 or X was 5. All of these would result in us getting a 0Y, which means we can just take the summation from 0 to C of the formula that we found previously for the previous section, right? Which would just be like this. Now, if we said X is more than C, okay, what does this mean? So this means that the minimum is C. So our formula becomes Y is equal to X minus C. Well, we can move the C here and say that X is equal to Y plus C. Well, we have a formula for X, right? Our formula for X was this, right? If you remember correctly, up to B. And here we are thinking about all the numbers less than B because C was set to be less than B. So we only take the part where less than B, the formula for less than B. Well, instead of the X here, right, or the K here, we write Y plus C. So we can say Y plus C or K plus C, whatever, right? Which just gives you the formula of E minus lambda, lambda to the power of Y plus C. Here it's supposed to be small y, so we can say Y plus C, divided by Y plus C and exclamation point. Here, our Y, K, it really doesn't matter. And this sums up all the way from 1 all the way up to B minus C minus 1. B minus C minus 1. Now, why do we sum up to B minus C minus 1? Right? Well, we want C to be bigger than X, X to be smaller, right? Because B minus C, if C is